Alright, we have a bell ringer up. Let's get our bell ringer folders out and start working on it. This has to do with dependent and independent events like we talked about yesterday.
We're the four.
Everyone should have their bell ringer folders out. We need to be working on our bell ringer right now. Guys, working on our bell ringer doesn't take talking, okay? Just as a reminder, if you don't remember what we went over yesterday, let's do number one together. First off, how many total socks do we have? We got 1 plus 3, 4 plus 2 plus 2 gives us 8. So, for the first part, our probability of getting a black sock, how many black socks do we have? We have 2 black socks. We take 2 over our total number of socks. Now remember, we are not replacing our socks. So if we just took out 1 sock, how many socks do we have left?
7.
7. And how many black socks or green socks can we choose?
Oh, wow. 2.
We have 2 green socks. So we have 2 out of 7. Now when we multiply, remember we can reduce these 2. This will become a 1. This will become a 4.
114.
What is 4 times 7?
28.
28. Good. And now can we reduce that?
114.
Good. 1 over 14 for number 1. Now you need to go through numbers 2 through 8 on your own, just like what we did up here. Remember, for our second one, if we took out a sock, we need to change our total number.
It's just got small words. No.
Dylan, do you need a calculator? Yeah? Dylan, would you like a calculator? Does anybody else need a calculator?
Yeah.
Who else? Did anybody else need a calculator?
Oh, he's gone today.
Gone today?
Yeah.
Did he leave early?
Wait, he left early?
He was here? Let's focus on our bell ringers, not quite so much talking, okay? guys focus so much on yourself.
I could do something more fun.
What's 4 times 8?
This is fun.
32.
Andy, we're gonna do something fun today, don't worry.
Yes, score!
Guys, we'll talk about it later. Right now, we're working on our bell ringers.
Wait, we didn't have 3.
You guys, 2 more minutes to work on your bell ringer. Or let's see. I'm gonna give you 1 more minute actually. Okay, 1 more minute to work on your bell ringers. Try to get a couple more done. Hey guys, we aren't talking. We're working on our bell ringer right now.
Two negative.
You should go like this.
Let's look at number 2. I'm gonna erase number 1. For number 2, how many Red Sox do we have?
1.
We have 1. How many socks do we have total?
8.
8, good. Then if we take a green sock, how many green socks do we have?
1.
2.
Green socks, how many green socks?
2.
2. Out of, what is our total if I already took one?
7.
7, good. Then we multiply them. What is 1 times 2?
2.
Ashton.
2.
2.
But you can reduce.
You're right,
One
we can't
fourth.
reduce. Sorry, I forgot about that step.
1 4. 1 4.
What is 1 times 1?
1.
1. What is 4 times 7?
28.
28. So our answer for number 2 is 1 over 28. Number 3. How many blue socks do we have?
Double on 3.
3 out of our total.
8.
Now, if I took a blue sock out, how many blue socks do I have left? 2. Alright, I took 1 out. 3 minus 1 is 2.
7.
And my total has once again gone down to 7. If we reduce, we have 1 and 4. 3 times 1 is 3. And we did 4 times 7 as 28. Let's look at number 4. How many green socks do I have?
1.
2.
2.
Told you.
2 out of my total, 8. If I take away one of my green socks, how many are left?
0.
1.
Wait.
How many green socks are left if I took 1?
1.
That's just how I'm
Over our total is 7. What will that give us? What is 8 times 7?
50.
56. And can I reduce that?
Yes.
1 and
To what?
23. 20 something.
28.
28.
28. Good. Number 4 is 1 over 28.
28.
Okay, now, did you all write this down? Because I got to erase it now.
Yeah, I did.
Okay. For 2 black socks, how many black socks do we have? 2. Good. Out of our total, 8. If we take 1 away, how many do we have left? 1 out of 7. Same as the one before, so it's still going to be 2 over 56, which equals 1 over 28. Okay, that one's the same as number 4. For number 6, the probability that we take a black red sock. So, how many black socks did we have?
2.
We said 2 out of 8. Then, if we have a red sock, how many red socks do I have?
1.
No.
1.
Yeah.
1. Out of my new total, 7, which, same thing as this one. Sorry guys, lots of repetition today. Okay, probability of a red sock. How many red socks do I have?
1.
1. Out of our total,
8.
Wait, 8.
total of 8. And we have 2 blue socks.
Oh, yes.
Nope, sorry. How many blue socks do we have?
3.
3.
8.
3 out of how many?
8.
7. Good.
Why 7 though?
Why 7?
Because you took 1 sock.
We already took out one.
Because if I had 8, for this example, rags, and I take 1 away, how many are left?
7.
7.
7. So that's where we get 7 for our new total.
Alright.
Okay? Because I took 1 away, and now if I'm choosing another one, I'm choosing 1 out of 7.
That's 6.
No, because this was 8. If I took 1 away, but I'm choosing 1 out of how many do I have here?
7.
7. So
Oh.
I'm choosing 1
I get
out
it.
of 7.
I got it. Good.
Oh, tickle.
I don't know. I didn't work. I'm not sorry. 1 times 3 is 3.
3.
8 times 7
About
is
56.
Can we reduce that at all?
No.
Why not?
Because we can't.
Because you can't reduce 3 to 5. Right?
Nobody can reduce your plate.
You can reduce 3
Yeah,
to 6.
you can.
Do you remember the trick of how to determine?
Yeah, you add them together.
Good.
Oh,
You
it's
add them
11.
together. 5 plus 6 is 11. If 11 is divisible by 3, then you can reduce.
Yeah.
But we can't.
No, it's not.
11 is not divisible by 3.
11.
Alright, so we cannot reduce our fraction. For number 8, what is the probability that we choose a blue sock?
1 8.
1.
How many blue socks do I have?
3.
Great.
Wait, 3.
Great.
Wait, no.
Three, guys.
I've got 3
Great.
blue socks
Where did I get
out of
1
my
from?
total of 8.
Red.
How many black socks do I have?
2.
Those.
Go. Straight.
1
Look up here if you can't remember. 2 out of my new total. Ashton, what is my new total? If I took 1 away.
7.
7. Good. What is 3 times 2?
6.
6.
6. We can reduce 8 to 2.
Oh, you
Carson,
can't.
don't get ahead of yourself.
I'm not gonna add myself. I'm gonna
Carson is holding me accountable because I keep forgetting that step. So thank you, Carson, for holding me accountable.
No, it's not for the rest of the year. Okay.
No, I think you'll still have a second.
3.
3 times 1 is 3. 4 times 7 is
28.
28.
Are you an alien?
Go ahead and put away your bell ripper folders and take out your worksheet from last night. Remember your worksheet on dependent and independent.
I don't understand. And
It goes like that.
slow.
Alright, we have a lot of stuff that we need to go through today. So I'm going to answer 3 questions. Alright? If you have more questions than what I go over, you need to come and talk to me later.
Okay.
Troy, what is your question?
29.
29.
Yeah, look good.
I guess.
You guys should have your worksheets out and be following along.
1 over.
29. Suppose you pick 3 cards from a standard deck of 52 cards without replacement. What is the probability that all the cards will be red? How many cards in a 52 deck of cards are red?
26.
26. Good.
Half of them. Wait, no,
So we
that's
have
26.
26 red cards.
Actually, we get 2 jokers.
It's true, but one's black.
Now we're not replacing any. So if I choose one of my, okay, let's see. We want probability is that all the cards are red. So this is an independent, a dependent outcome, okay? Dependent event. This is exactly what we were just working on, all right? So how many total cards do I have? 52. How many of them are red again? 26. So my probability for my first one, I have a 26 out of 52 chance. If I draw another card now, I didn't put my first card back. So if I draw another card, what is my probability that it will be red?
25 out of 52.
51.
There's still the same amount of cards though.
Just like with the reds, I took one out
I'm confused.
and I kept it out. Now we want to know my probability of taking another red card. So for our example, we're going to say that each time I've picked a red card so far. Okay? We're going to say that I have. So I picked a red, Queen of Hearts, and then an 8 of Diamonds. Now, how many red cards are left?
24.
24. And how many total cards do I have?
50.
50. Then you need to multiply that out. First off, we know that this can be reduced to 1 over 2. What can be reduced 24 over 52?
12 over 25.
25 and 25 cancel each other out. And then we can also look at these two. I know that they're a bit far apart, but they're going to cancel each other out as well. Does that make sense?
6 over 51.
Good. Our answer will be 6 out of 51.
What did you reduce it?
I got 217.
Yeah, that's what I got.
Can you reduce it more?
Yeah.
All right. How can you? So you said it reduces to 2/17.
Yeah. No. Yeah, that.
What good?
I have a question.
Yes.
Okay, in a standard deck of cards, if you're counting the jokers, isn't that like 50?
We're not going to count the jokers though. We're just counting all of our number and face cards. Yep. We took our jokers out. All right. Are there any other questions? Chad, do you have a question?
Number 32.
Number 32. We need a combination of 6 things taken 5 at a time. So remember, how do we do a combination?
Times 2.
Stuff and then divided by some other stuff.
Like 2 times.
So 6 times 5 is 4. Do I go all the way down to 1?
No!
Nope, we only need 5 numbers here. What do I do next?
Divide by 5 factorial.
Good. Now if we look for things that can cancel out, our 2's, our 3's, our 4's, and our 5's will all cancel each other out. So our answer is going to be 6 over 1, or just 6.
We done it before.
Oh, I got that in my.
Isn't the same thing that you got?
Oh, sorry.
Mhm. Yes. So you could have multiplied all of them out. Andy, when you multiplied them all the way out, what did you get?
728 over
Did you get 720?
Alright, so you could have multiplied and gotten 720 on the top and 120 on the bottom, which would still reduce to 6 over 1. Last question. Are there any other questions? Ashton.
Never mind.
Okay. Alright, go ahead and pass your worksheets to the front. And then take out your notes booklets. We're taking notes today.
So I want you to have it. No, I don't want it. I want questions.
Okay, guys, it doesn't take talking to take it out.
They're being mean.
Okay, Allie face front then, okay? Just ignore them.
What? Even Andy
In your notes booklet,
experiment.
turn to the last page. And I know that we took notes on this last page yesterday on the top. Remember I said on the bottom we need to write 2 different lessons. So after lesson 5, put a slash, put a line, whatever you need to know that there are 2 different here. And then write lesson 6, experimental probability. And today we're going to be working with experimental probability.
Fix it.
So first off, I'm not going to do this entire example because it's going to take us too long. Okay, but to give you an example, it says a paper bag containing 10 marbles. We're looking at a paper bag containing 10 marbles. So we would draw 1 marble from the bag, record its color, and put it back in the bag. For this example, are you guys paying attention? So I don't have marbles and I don't have a bag, but I do have colored dye and I have a container. So I would take one out, it's blue, and I would write down somewhere blue. Then I put it back. Mix them around, take out another one. I got black this time. Put it back, mix them around, red. And I would do that 50 times. Okay? It would take a very long time to do it. Now, inside of here, I have 4 blue. So I'm just going to write it in my blue marker. 4 blue. I've got 3 green, 2 reds, and 1 black. 3 blue dice, 4 blue die, 3 green die, 2 red dice, and 1 black die. Now, we would figure out a ratio. After we had done this 50 times, we marked down every single color that we chose. We would make a ratio. So let's say I was counting all my greens. And I pulled out a green, we'll say 17 times. So I pulled out a green 17 times. I put the number of times I drew my green. Over the total number of draws, I picked out a color 50 times. I picked out a dice 50 times. So I would have 17 out of 50. When I did this experiment, I took out a green die 17 times out of my 50 draws. That's what is called experimental probability. That's where I actually did the work. I figured out what my probability would be. Now, what theoretical probability is if we count up the marbles and we figure out a ratio of marbles. So for this one, remember I have 3 green. So we would have the number of our green marbles, which is 3, out of our total number of marbles. 10. 3 out of 10. Now, our ratios, we would think would be the same, right? Okay, because if I converted this to 50, I take 10 times 5, so 3 times 5, is that right? Yep. I would expect that out of 50 draws, I would draw a green one 16 or 15 times. Are my ratios the same there? No. Why not, Courtney? 17 over 50 and 15 over 50. Are they the same?
No.
Why not?
Because one's bigger than the other one.
One is bigger, that's true. So, when I did this, and I actually drew out a die each time, I got 17, but I thought I would get 15. That's how we find experimental and theoretical probability. Theoretical is what we expect to see. Experimental is what we actually find. Don't worry, we're going to do another activity with this.
Yay.
But first off, I want you to write down the definitions.
Wow.
Our first definition is here. It's underlined for us. Probabilities. Yes, write it on the bottom, please. Probabilities. based on frequencies obtained by conducting an experiment are called experimental probabilities. Now I realize that the word we're defining is at the end, so you can circle it if you want, or you can just switch the order. Okay? You guys know how to switch that word to the front if you are confused by the order of the sentence. So our first part is experimental probabilities. Now you also need to write down the second definition, which is also underlined. That one says, probabilities based on known characteristics or facts are called theoretical probabilities. For that one as well, if you write it down the way that it's written there, circle theoretical probabilities so that you know which word you're actually defining. Otherwise, switch it. You guys know how to switch it. You just take the word, put it in front with a colon, then put your definition.
Is your professor
The bathroom.
No, he's literally sitting in the back.
Yeah, it is.
Oh, I see him.
Okay. Let's focus on our definitions today. Carson was asking where you were. And so John said he's in the back, and Carson thought John said he's in the bathroom.
Okay, I'll go
So
talk
they
to
were
them
laughing.
first. Guys in front,
Really?
Second person.
Okay, Carson. Focus on John. Right now we're not talking. Start talking to everyone. We're just writing right now, guys. We don't need to be talking to each other. Now, Andy, you asked why we couldn't do something fun today, which hurt my feelings a little bit. I thought we had fun every day. But today we're going to play a game. However, it's not just a fun game. We need to figure out probabilities first. So you're going to be working with your table partner to figure out these probabilities.
We don't know crap about that.
That's okay. I'm going to walk you through it so we can figure it out. Now, all right, listen up, guys. Up here right now. Okay, so what our game is, we need to figure out if our game is fair. So to figure out if our game is fair, that's where we're going to figure out our probability before we start playing. So with our game, you and your table partner will each get a die. You're going to roll your die. So if Andy and I were playing, Andy, roll your die. And I roll mine, and I get a 5. So we need to take 5 minus 5. 0. Now let's say that I get a 4 instead, okay? Just for this example. Take the larger number, which is 5, and subtract the smaller one, which is 4. And so we get 1. Andy is player A. Every time that we come up with an answer that is 0, 1, or 2, Andy will get a point. If we come up with an answer that is 3, 4, or 5, then I will get a point.
It's cheating.
Why is it cheating?
Because he gets 2, or only gets 2 and you get 3.
Nope, he gets 0, 1, or 2.
But you can't get 0 on the dice.
They can.
We just did.
If you're
What's 5 minus 5?
5 minus 5, 6 minus 6, 3 minus 3.
Or if you just
minus
you're
two.
subtracting the
I am
two.
so confused right now. Go on.
Okay. I'll go help you in a moment, Ashton. Now,
I have the advantage.
hang on. Listen up though, guys. We're going to go through this step by step real quick. First off, we need to figure out the probability that that Andy will get points and the probability that I will get points. The way we're going to do this is I have this grid. So each of you at your table will get a grid. First of all, you need to go through the grid together and figure out each one, what is the difference. So for example, if you look at this grid, and hang on, I'll put it up in the front because I've got one in the front too. So let's look at our first square. Look up in the front. Let's look at our first square in the top left-hand corner. Alright? Now, if one player gets a 1, and the other gets a 1, what is 1 minus 1? 0. So you need to write a 0 in the first square. Now let's move down. So now we're going to move down to 2 and 1.
Do you write that?
Yes, write it in on your grid.
On your grid.
0 in that first square. Now let's move down to our second square here. We take our larger number, which is 2, minus our smaller number, which is 1. What is 2 minus 1?
That's all we do.
Yep, that's all you need to do.
We don't even get dice.
Take your next one. 3 minus 1. 2.
2.
You need to fill out this whole chart with your table partner. So go ahead and work together if you guys are confused or having trouble. Everybody needs to fill this out, so everyone needs to get working on it.
1 minus 1.
Troy, why don't you move up next to Caitlin and work with Caitlin?
You get negative?
I'm giving you guys a limited amount of time here. Take the bigger number minus the smaller number.
So you take 1 minus 4.
For example, what if I'm doing this one?
You would take 3 minus 2.
I would take 3 minus 2. My larger minus my smaller. Ruben, are you working on it too?
So 1 minus 2.
You need to fill out yours as well.
Is there any negatives?
No, there are no negatives. You're not taking 1 minus 2, you're taking 2 minus 1.
You have, bro.
Oh.
Oh, it says raining. Wait,
It is raining.
Just what?
Yeah, that's worse.
That's bad.
Yeah, that's worse.
We have to run.
You?
We have to
Don't
run.
you remember the last time we were inside? No.
That was terrible.
Who's our day to live?
We don't live.
You will. Today.
No.
And today's usually a Friday. So, I was going to go.
Because
What day?
he's monkey. This is not wet. What? This is not
No, we can
wet.
play that.
Once you have your chart filled out, look up at the front. I'm going to help you out with the next part.
You guys do that for for tomorrow.
Alright, I gave each of your groups.
Yeah, I for tomorrow either.
Listen up here, please. Adam. Guys. I gave each of your groups 2 different colors of colored pencils. So what you need to do is choose one color and decide, this is going to be my color for every point that player A will get. Remember, A gets any number from 0 to 2. B will get any number from 3 to 5. So you need to color in all of the points for A. For example, this one is a 0. I'm going to color that in for A. This one is a 1. A gets that one. This one is a 2. A gets that one.
We're not coloring it in right now, are we though?
Yes, go ahead and color it in right now.
Because what?
Listen up here, okay? This one is a 3. Who will get 3?
Me.
Who gets the points for 3?
B.
B.
That's kind of cheating.
Color it in your color for B.
There's way more
color in
Zero
all
for
of your
two.
zeros.
Yeah.
Whatever color you decide is going to be player A. Because player A
Guess what?
So.
gets every zero. Does that make sense? They get a point.
About
every
six.
time
Point,
zero.
put
Are you coloring yours?
You win.
You need to color them in two.
Is this
Regardless of what player you are, I want you to color in both of them. Whether you're player A or player B, you need to color in both colors. Player A.
Yeah, so arguing about which one gets one.
There, I'm done.
What?
I didn't forget anything.
Player A also gets every one.
Idiot.
Now, I completely forgot that I was going to ask you this before we started, but you and your table partner need to decide who wants to be A, who wants to be B.
Yeah, because
Talk to your partner and decide if you're going to be A or B.
I'm A. I got this on A.
You guys have 5 seconds to decide. 5, 4, 3, 2, 1. Okay. Now A also gets every two.
I vote Cody's A.
I'm on Malia.
What are we voting?
Okay. Now, you guys all figured out whether you're player A or player B.
Player A.
Now I want you to look, Allie, up here, please. Now I want you to look at your paper and count up how many total squares do we have?
36.
We have 36. So our total number of squares is 36.
Wait, we have to put that somewhere?
Hang on. Now, for player A, I want you to count up how many squares or how many possibilities are there for player A to get points. Any number that's 0 or 1 or 2, player A gets points.
That's what it
I
don't get it.
Player B, it should be green.
is.
Does that make sense? So notice that you put because player A gets those points. That 2 should also be green.
You dummy.
How many squares or how many possibilities do you have for player A to get points? 24. To figure out our probability, we take the possibilities for letter A, remember that's 24, over our total, 36. What can you reduce it to, Carson?
12.
12 over 24.
1/2.
That's not right then.
I just said 12. 12, it's 1/3.
Close.
2/3.
2/3.
2/3. Good.
3/3.
2/3 because, listen up, 2 times 12 is 24, 3 times 12 is 36. For our next one then, count up all the possibilities
Jose.
for player B. All your possibilities for player B to score points.
12.
Has everybody counted them? Has everybody counted them?
Yes. So,
My hand's up first.
How many do we have for player B? How many possibilities? Chad?
12.
12. So we have 12 possibilities for points out of our total, which is 36. And what can I reduce 12 over 36 to? 1/3. Good.
So it's not
So-
fair.
This is our theoretical probability. Nope.
Is that the game?
No. Listen up, guys. This is our theoretical probability. Are you all listening? This is what we would expect to find. this is what we think would happen if we were to do this. Now, we're actually going to do this, okay? You guys have already decided who is A and who is B. So I want you to flip over your paper.
Right now.
Okay, guys, stop messing with the dice. Listen up. Listen up. And now, what you're going to do, each of you is going to take a die. Roll your die and take the larger number minus the smaller number.
We gotta say what?
Then it's 0.
Okay.
So player A gets the point.
Roll your dice.
Right? So remember what your possibilities are. A gets points for 0 for 2.
Yeah.
B is going for 5. Guys, hey. This does not mean that you are all yelling at each other. We're quietly playing the game. Put tally marks on the back of your paper for each of your points. Shania, do not yell. Raise your hand. Yes, Shania.
Okay, this is great. Go grab it.
Five.
Yeah.
You need to play this 12 times.
We get 4 points.
Okay,
Yes, that's right.
So you guys already 12 points?
Yep.
I got it.
12 times.
Yeah, one loss, the lower number, A always wins.
There you go.
A always wins. It's cheating.
This game is rigged.
I won.
Last one for the time.
I beat the odds. Actually, I beat the odds.
Once you have rolled 12 times, please stop. Do not keep rolling your die for fun.
You just was slacking off when I called
And you gotta take your ball. The last 3 points. You got the last 3 points. We got 12. Alright, we're almost out of time, so everybody hold your die. We're good.
This is
Okay,
not
now
real.
sit down.
This is so complete.
Ashton, Troy, hang on. That's impressive. You guys are staying seated here until I'm done talking, regardless of when the bell rings. So everyone needs to quiet down and listen up. Alright, now I want you to count up how many points you got and take that out of the total numbers you played. So we played 12 times. So you need to take your number of points out of 12. Alright, figure out your probability. Your probability. The number of points, so the number of times that you got points, over 12. Andy and Megan, who is player A? Andy, how many times did you win?
10. See, A always wins.
I beat the odds.
Troy and Kaylee, who is player A? Kaylee, how many times did you win? 4. What was your probability then?
Boy.
4 out of 12. Shania and Dylan, who was player A? What is your probability? Okay, just take 2 off. Because I want to know how many. So you're player A, and you won 1 out of 12.
No, it's not.
how many times, what is your probability for winning?
6 out of 12.
We got a good one.
I did it, Troy.
John and Austin, who was player A? Okay, and what was your probability? Up here. You guys should be paying attention up here. Stop messing with your dice. Everybody put your dice on the table and stop touching them. I'm serious, guys. I'm not writing you any notes for being late. You guys are staying here till the bell rings. Even after the bell rings. Okay. So our probability for player A. What was our probability for player A winning? Do you guys remember? Our probability for player A winning.
24 out of 36.
24 out of 36, which is 2/3. Player A was 2 out of 3. If we change that to something out of 12, we take 3 times 4 to get 12. So what is 2 times 4? 8. Good. We're taking 8 out of 12. Now, look at all of the probabilities that we got there for people who were A and were winning. Are they all equal to 8 out of 12?
No.
No, they are not. So the thing that we can see here is 8 out of 12 was our theoretical probability. If this was a perfect world, everything always happened as we thought it would, everybody who was player A would have won 8 times. They would have gotten 8 points out of 12 rounds. Alright? But this is our experimental probability. Our experimental probability is when we test it, when we actually figure out what is the probability, which is exactly what we did with this dice game. We figured out that Shania won 11 out of 12 instead of 8 out of 12. We figured out that Andy won 10 out of 12. Kaylee only won 4 out of 12. So when you're looking at the difference between theoretical and experimental, theoretical is what we would expect to happen. Experimental is what we figure out happens. Okay, so that's the end of the game that we're playing right now. Now, I have a little bit of a challenge, though, that I want you guys to think on. Yep, you can do it. I think you guys can do this. Right? I have every faith in you. 2:37. Okay. Actually, again, I misjudged time. I'm sorry, guys. I always get the times mixed up of when we start and when we end. So class is actually almost over. So, first off, I want to say thank you for quieting down at the end and paying attention, okay? Because we needed to get through that because I wanted you to understand theoretical and experimental. Secondly, we have a test on Tuesday. A test over all of this probability stuff. On Monday, we are going to be reviewing for our test. We're going to be going over what we learned. We'll talk about some problems, do some sample problems. But remember, your test is open notes. So all of these yellow booklets of notes that we made, you guys can use them for your test. If you missed a day of notes, I suggest that you get the notes from a friend. Okay? I want everybody's eyes up here. Okay? Because I want to make sure that you're all paying attention. Be sure to get the notes from a friend if you don't have them. And maybe this weekend, if you have time, look over your notes. I know that maybe you don't want to, but look over your notes and figure out maybe the difference between permutations and combinations. You guys had trouble with that. We'll go over it some more on Monday, but tomorrow we have career day, so we're not going to be, well, we will be having class, but we're not going to be working on
Just
this.
before they leave, one thing about that, so whenever you're done, just let
Okay.
me know.
So yeah, Shania, do you have a question? Yes, you may throw that away. Now, Mrs. Stofferness, I'm going to say about career day.
Okay, and I don't know, just because I just got back here a while ago because I was out of town. I don't know if you have already heard this or not, but tomorrow morning, you need to be at school at 8 o'clock because they're going to have you go to your homeroom right away at 8 o'clock in the morning. If you come late to school tomorrow, don't go yet. If you come here late to school tomorrow, you probably will not get to go down to Sheldon. You'll have to sit next to Rand's office.
Boulevard
So you
students
have
to
to
report
be
to the
here
office,
tomorrow at
Becca
8
Schmidt,
o'clock.
Jacob
Just
Jones,
your
Homestead Deacon, Jasmine
bus is
Johnson,
open over
Cole
there.
Newman, and Colvin
And if you're
Dennis.
here after 8:15, they plan on leaving, so if you're not here, you'll get left behind. The second thing is, when you go to your homeroom, You need to bring a pencil or something to write with because you are going to have to take some notes and your homeroom teacher will explain what's expected of you. The other thing is if you have a phone, and I'll remind each homeroom teacher will remind you this, you cannot bring it to the college tomorrow. They will confiscate and take your phone if they see it. So you are not allowed to bring your phone with you tomorrow. So you will be reminded of that again tomorrow. But if you want to give it to your homeroom teacher, I'll take yours because I'm actually going to be here. Mr. Wiersma, I think, and you'll have to check with Fuji to see what they want to do because some of the teachers are having you keep them in Mr. Miranda's office. But I'm not going tomorrow, so I can keep it home.
Wait, before you leave. One person needs to bring the dial, please. The other person needs to take the pencils over here. I need the dial here.
Oh, don't worry, Adam.
Cody?
Float it in, huh?
I just did a couple times.
Shania, Dylan, put away your pencils. Allie, there's a pencil left on your desk.
Oh, there's a dice on
I'm
the
gonna be late
table
for
up there.
work.
Sorry.
Just saying, I'm just making a standing ovation that I imagined what we were doing.
Very nice, Carson.
Look at that, that's skill.
Thank you,
They've
Allie.
done a different
Prove it
thing,
here.
so you are assigned.
Right there,
You guys
Carson.
Thank you, guys.
You're assigned to
So what was that camera
classes
for?
based on your interest.
Hang on, Carson, I'll tell you in a moment.
Hi, camera.
Something you like,
All right,
Yeah, you're
Carson.
funny.